I'm going to go over a few of these inverse and direct and joint variation problems. So if you have to write an equation over here, your equation needs to involve k. You need to actually solve for k. So what I do first is I take this statement, y varies inversely with the fourth power of x, and write a general equation, y varies inversely, so that means that whatever follows inversely is going to go in the denominator with the fourth power of x. So it's going to be k over x to the fourth. K is always in your numerator. Then I use the second part of this information to solve for k. So I'm going to plug in 5 equals k over 1/2 to the fourth. 1/2 to the fourth is 1/16, and since I'm dividing by 1/16, I'm actually multiplying by 16. So this is actually 16k. So to divide by 1/16 is to actually divide by, or multiply by 16. So k is going to be 5/16. So my equation is going to be, it needs to include the k that you just solved for, y equals k, which is a fraction, so I don't want to write a fraction over another, or two fractions, so I'm going to put 5 on the top and 6 on the bottom, and then x to the fourth is also going to go on the bottom. So there's my equation, it has the k in it. So then I'm going to solve for y, so right here it is find y when x is 1/3. I'm going to plug in 1/3 for x. So it's going to be y equals 5 times over 6 times 1/3 to the fourth. So order of operations, I'm going to do 1/3 to the fourth. So that's 5 times over 6 times 1/81. So if I divide by 1/81, it's actually the same thing as multiplying by 81. So this is going to be 5 times 81 over 6. So that is 67.5. Or you could do 81 divided by 6. I could divide both those by 3. So it's going to be 5 times 27 over 2. So 5 times 27 is 135 over 2. That's how I get 67.5. Okay, so when you write your equation, you want to plug this back in and solve for k. So let's look at other ones here. Number 2, y varies jointly with the product x, y, and inversely with z. So I'm going to set this one up, and then you can go ahead and solve for k. So y varies jointly. Jointly just means more than one direct variation. So this is going to be k xw over z. Now you'd want to solve for k by plugging this in and writing that in your equation. Okay, second one, z varies directly with w and inversely of the product of x and y squared. So z varies directly with w, so kw, and inversely, because this would have to go in the denominator, of xy squared. So again, you're going to want to solve for k by plugging in this and writing it right here. Z varies directly with x and inversely with y. So z varies directly with x and inversely with y. L varies inversely with w, so it's just going to be L equals k over w. A varies directly with p and inversely with q. So A varies directly with p and inversely with q. And then again, you would go through and plug this in, figure out what k is, write your equation with the k value, and then plug in these unknowns to solve for p. This is an example of a reciprocal function right here. Y equals 8 over x. So what I would do first is I would graph the asymptotes. So the asymptotes are going to be x equals 0, because you cannot divide by 0, and also y equals 0. It is the parent function y equals 1 over x, and it hasn't been shifted left or right, so the asymptotes are y equals 0 and x equals 0. The directions read to list 4 points of each graph in the chart. So what I'm going to do is I'm going to plug in values for x and evaluate my function up here. So if I plug in 1, I get 8. If I plug in -1, I get -8. If I plug in 2, I get 4. If I plug in -2, I get -4. So I'm going to plot these points. I went through and actually did the point 4, 2, 2, 4, -4, -2, and now I'm going to connect them, okay, with a smooth curve and put arrows at the end. So if the red lines are the asymptotes, y equals 0 and x equals 0, this graph is going to get close to these red lines, but it's not going to cross it. So you want to make sure you put arrows on both ends. Okay, second one, write the equation for this graph after you have a translation and it has asymptotes of x equals -3 and y equals 2. So you're taking this function and you're shifting it, basically you're shifting it so that it has x equals -3. So you are shifting it left 3 and then y equals 2. So this new function is going to be y equals a over, well, if your asymptote is x equals -3, it's going to be x plus 3. And then you're moving it up 2, so it's going to be plus 2 right here. So what you can do is plug in values for x in this table. Looking at this number, I'm going to plug in 5, because if I plug in x as 5, it's going to be 8 over 8, which is 1 plus 2 is 3. I could also plug in -1. If I plug in -1, I'll get 8 divided by 2, which is 4. 4 plus 2 is 6. So I'm just trying to think of numbers that would be simpler to plug in. So I plugged in more values, and I also noticed, now this is symmetric right across here. So if you look at if this is your new origin, think about how you're going right to up 4. You're going to go down to left 4 to get that new point. If you go right 4 up 2, you're going to go left 4 down 2. So you could also look at it that way. Okay, I'm going to be going through parts of these. Make sure you can also graph them. You actually want to show any holes, vertical asymptotes, and horizontal asymptotes. So for the first one, the first thing that you want to do is check for if there's any holes. So holes would be a common factor on the top and the bottom. In this case, there's not a common factor on the top and on the bottom. So then what I do is I find the vertical asymptote. So the vertical asymptote is when you set the denominator equal to 0. So the vertical asymptote is going to be x equals 0 and x equals 3. When you do the horizontal asymptote, you want to look at the degree. So the degree of the numerator is degree 1. The degree of the denominator, once you distribute that 2, is going to be x squared, which is degree 2. So if the degree in the denominator is higher, the horizontal asymptote is going to be y equals 0. So if the degree in the denominator is greater, it's going to be y equals 0. If the degree in the denominator is less, then it's going to be no horizontal asymptote. And if the degrees are the same, you're going to take the ratio of the leading coefficients. So number 10, looks like this one's not factored out, so I actually want to factor it. So I have x squared plus 10 does not factor, but then I can factor out a x out of the denominator. So there's no hole because there's not a common factor. So the vertical asymptote is going to be x equals 0 and x equals 4. And then if I look at the degrees to figure out the horizontal asymptote, the degree right here is greater than the bottom, so there's no horizontal asymptote. Okay, number 12, or number 11. I'm going to factor out the top. So the factor out the top turns into x times x plus 2, and the denominator turns into x plus 4, x minus 2. So I'm looking for common factors. So to find the whole, there's not a whole because this is not the exact same common factor. So then I'm going to find the vertical asymptote, which is x equals negative 4 and x equals 2. And then the horizontal asymptote, you want to look at the degree. Well, here the degree of the leading coefficients are the same. So if you put, or the degree are the same. So what you're going to want to do is look at the leading coefficients and take the ratio. So the horizontal asymptote is going to be y equals 1. Number 12, you're going to want to factor out the top. I'm going to do the grouping method. In this case, I did the grouping method. You can factor it however you want, but I did multiples of 3, or factors of 3 times negative 10 that add up to 13, which is 15 and negative 2, and then I factored this out by grouping. So now this is my polynomial, or this is my rational expression. So I have, now, excuse me, I can see the discontinuities better. I can see that I have a whole, so my whole is going to be at x equals negative 5. So what you can do is you can figure out what the y value is for the whole by plugging in negative 5 after you remove the whole. So if you plug in negative 5 into this expression right here, you get 17 over 13, and you can do that off to the side. Now I'm going to do, after I have the whole out, I'm going to do the vertical asymptote. So the vertical asymptote is after you get rid of the whole, set the denominator equal to 0. So the vertical asymptote is going to be x equals 3 halves. And then the horizontal asymptote, you want to look at the degrees. So right here you have degree 2, and you have degree 2. So you're going to take the ratio of the leading coefficients, which is 3 halves. So the horizontal asymptote is 3 halves equals y. Oops, should be an equation. Y equals 3 halves. Okay, let's look at number 13. I'll do one more. So 13, you're going to want to factor out the top. So it's going to be x minus 4 times x plus 3. And then I factored out the denominator by grouping. Actually, I just did guess and check because I thought it would be faster because these two are both prime. But anyway, now you have a whole right here. So your whole is going to be at negative 3. So the whole is going to be at negative 3. And after we remove the whole, we're going to want to plug in negative 3. So I'm going to plug in negative 3 to this expression. And I get 1. So there's a whole at negative 3, 1. So when you're graphing this, you'd actually put, at the point negative 3, 1, you'd actually put an open circle to represent the whole. So the whole is negative 3, 1. The vertical asymptote is going to be x equals 1 half, because you're going to set that equal to 0. And then the horizontal asymptote is you want to look at the ratio of the, or you want to look at the degrees of the numerator and denominator. In this case, they're the same. They're both x squared. So it's going to be y equals 1 half. It's going to be the ratio of the leading coefficients.